Hello everyone, my name is Lynn Nethkin and welcome to the EGR 219 Computational Modeling course using MATLAB with Dr. Sangram Redkar for the summer 2015 course at Arizona State University. We are going to start today by going over Chapter 1 from your book, An Engineer's Guide to MATLAB. We're going to kind of go through it section by section. We'll go through these PowerPoints and then we will also show some examples directly in MATLAB so that you can start becoming familiar with the environment. So the course objective is to introduce you to the fundamental characteristics of MATLAB, the environment, and then as well as the language's syntax. We're going to do a lot of application using MATLAB to all kinds of different engineering problems. So we'll go ahead and get started here with Chapter 1, the introduction. And here's just kind of summary for you, the sections that will be covered in this chapter. Like I said, we're going to kind of go over these briefly just to give you an idea as to what the context is about for each of these chapters. I do highly recommend, though, that you read this chapter in detail. It's a very important chapter because it really gives you the basis for how to use MATLAB. So what is MATLAB? It's a computing language devoted to processing data in the form of arrays, which are called matrices, and we'll go more into detail about what exactly those are and how you create them in MATLAB. It integrates computation and visualization into a flexible computer environment and provides a diverse family of built-in functions that can be used to obtain numerical solutions to all different engineering problems. It derives its name, MATLAB, from Matrix Laboratory. So when you first open MATLAB, there's going to be three primary windows that you're going to notice and that you're going to be using throughout this course. The first is called the workspace, and it's a display. It displays the list of all the variables that you have entered and defined, as well as their individual properties. There's also the command window, which displays the command prompts and the outputs from your scripts or your prompts. Then there's also the command history, which displays all the entries made in the command window during each session. So we'll go ahead and bring up MATLAB here so that you can see what this looks like. So when you first open MATLAB, this is what you're going to see. So again, here we have the command window. This is your prompt here. So this is where you can start entering text and equations and all kinds of things. We'll go through all different examples here. And then over here, you have your workspace. So again, this is where your variables are stored, and we'll go over that more. You'll also be able to look at the different properties for your variables and how you've defined them. Looks like we don't have the command history window here. So if you open it up and you don't have this default layout, what you can do is go up here and click on Layout. And then you can customize it to how you want to, and you can also save the layout as whatever your preference is. However, we're going to go ahead and dock the command history window. And so now you see here that it's pulled up this window, the command history window, and you'll notice that as you use MATLAB, after each session, it's going to create a new section and store your command history for that particular session. So that's pretty much the sum of it. We'll get into the current folders and whatnot. This is where you'll create different folders for your MATLAB files to help keep things organized. This up here is your primary toolbar. When you first open MATLAB, you'll see that you have the three different tabs across the top. You've got Home, Plots, and Apps. We're going to be going over all of these throughout the course, so just kind of look through this for now and start figuring out where things are. It'll help you when we go to use this shortly. So let's go back to our presentation here. So we've gone over the primary windows that you're going to be using throughout the course. Again, you have your command window, your workspace, and your command history, which you can kind of see down here. Every command that I entered through the prompt displays here for you so that you can see what you've entered in the past. Okay, so in terms of managing the command window, there's a couple of different functions that you need to learn. There's CLC, and this clears the command window. Clear all, or you can just use clear, will remove the variables from the workspace as well as clear the command window. There's also close all, which closes and deletes all the graphic windows that you might have open. There's format, which you can use specifically to format the output of your outputs to the command window. And then format compact will remove any blank spaces that you have in your lines. So we'll just show an example of that here quickly. So let's say that we have x equals 5, z equals 2, y equals 9. So you can see here, I've entered in each of these into the prompt. They've also shown here in my command history window. Additionally, they are up here in the workspace. So what the workspace does is I can double click on this and it'll bring up a new window for me, and it will tell me specifically what the properties are for that particular variable. So if we want to clear CLC, that cleared my command window. But you will notice over here that my variables are still here. If you want to clear the variables, then you also need to do clear or clear all, which now you can see that the variables from the workspace are gone. Okay, so moving forward, again, we can format the outputs and results from our scripts or from our command prompts. There's different things that you can do. So you can format short, or you can format long. You can format using short E, long E. There's all kinds of different options. Another one that's popular for use is to format rational, to convert from decimals into a fraction format. So real quick, we'll show you an example of that. So let's say we have something like, I don't know, square root of 3, and we're just going to define that as x. So right now we can see that that's kind of in a short format. So I can also do format long, and then I can do x, and you see how it has now displayed many more decimal points for me. I can also do format rational. And now you can see that it's converted that to a fraction format. There's also format E. Oh, sorry. Format long E. So now you can see that that has converted it to where there are still many decimal places, but now we have the E convention as well. And then you can do format short E. Okay, so then we see that it has removed all but the 4 decimal places here. So, you know, it just kind of depends on your application and your preference as to which one you're going to be using. But that is a good tool to know how to use. The text kind of goes over that more in detail, but it's pretty straightforward. Okay, so another important thing that we need to go over is creating variable names. And this is something that is critical in MATLAB. You're going to have to do this with pretty much all of the code that you write. But there are some particular rules that must be followed in order to create variable names in MATLAB. So first of all, you are limited to a number of 63 alphanumeric characters. The specific variable name must start with either an uppercase or a lowercase, and then it can be followed by any combination of alphanumeric characters. However, there is a limitation in regards to the symbols that you can use. So you are permitted to use the underscore character, but you cannot use any other characters. You can't use hyphens, exclamation points, anything like that. So it is also case sensitive. So for example, voltage, you see here there's the lowercase v, is different from this voltage, which has an uppercase v. So I can use both of these terms in the same script, but they are going to be different according to MATLAB because it is case sensitive. In terms of the variable names, it's important to know that there is a trade-off between the length and the readability of your code. So for example, let's say you define an expression as x. It may be helpful and more simplistic, and also can reduce computing time to have short variable names like that. But it can make it difficult for others to read and understand, well, what is X? What is that expression that you've provided? That's where comments come in handy, and we'll get in how to do those very shortly. Okay, so these are examples of the different types of variable names and how you can format them. So I've given examples that are permitted and not permitted. So exit pressure, again, you have the underscore symbol. You can also do, uppercase with a combination of lettercase, or you can do, lowercase, or you can do all uppercase, all lowercase, whatever your preference is. However, you cannot create variable names that have spaces between them. You can't use this, period, exclamation point, anything like that, or hyphens. Again, no other symbols are permitted except for this underscore here. Okay, so let's start by showing an example of creating a variable name in MATLAB. And you'll see here, I'm going to use the CLC to clear my command window just to bring it back to the top. So let's say that I have x equals 5. Okay, so right there I have created a variable, and that's why it's stored in this workspace over here. I can also do exit pressure equals 32. Okay, so now you see as well that it's stored this variable name up here. So very simple, but watch, I cannot do exit pressure. See how it's turning this purple color here? That's because MATLAB thinks that that is now a function. So we can't use that. Again, we can't do exit pressure. When we try to do that, it says undefined variable or function. So again, be sure that you're following these conventions when you're creating your variable names. Okay, so in addition to using variable names, you can also use the answer, which will display as your output when you don't define a variable. So we'll take this example here. Let's say that we have cos of pi over 3. Okay, so we're going to do format short, and then, okay. So we can see here how this output, the answer equals 0.5. I can now take answer, just as I would if I had assigned that as a variable. I can now take answer and I can do further manipulations with that. So I can now say, answer plus 2, and it will add 2 to this here. So MATLAB understands that that's a variable. Okay, so in terms of variables, there are some additional limitations. Particularly, there are keywords that are reserved exclusively for MATLAB's use. You'll know that you're using a keyword if you're trying to create a variable name with it, because it will highlight in this bright blue color. But we have provided here a list for you of the keywords that are reserved exclusively for MATLAB. We'll go through a lot of these so that you can see how they're used. But for creating for loops or while loops, cases, switching, things like that, again, just be sure that you're not using these for your variable names. Okay, so there's one other kind of notation thing that can be very helpful with your readability with your code. So there's something called suppressing the system response, and that is achieved using the semicolon. So you'll see here we have p equals 7.1 and then a semicolon here, as we do for this x and k expressions. So what that does is if I executed or ran the program, there will be no output displayed to the command window. However, if we don't use the semicolon and perhaps just use commas, for example, then it will individually display the values for p, x, and k that I have defined. So let's just show that in use here. So let's say we have x equals 5, semicolon. Now, nothing else was displayed. However, if we didn't use the semicolon, then it would give a system response, just registering that x is equal to 5 and displaying that to the command window. However, when you, especially as you start to get into your assignments and you're computing all sorts of different things in your code, you don't want every single line of code to output to the display window. You particularly want your final answer to display to the command window. So that's why we use this semicolon notation here. Okay, so the mathematical operations hierarchy is very similar to PEMDAS. Please excuse my dear Aunt Sally. It follows that same type of convention. The only difference is that there is something called prime, which uses the apostrophe notation. This is, we'll get into it, but that's a lot of used to transpose vectors and matrices. And so that's really the only difference. Otherwise, it follows the typical mathematical operations hierarchy. Okay, so we'll just kind of go over here, just some basic syntax so you can kind of see how you would write out an expression in MATLAB. So if we wanted to type, say, DC up to the x plus 2, this would be the notation that you would use in MATLAB. So this is your multiplier, this is for exponents, this is for division, you know, and addition, subtraction, you know, they're all your typical conventions that you use. There are some limitations in terms of matrices and vectors, and there are times where you have to use something called dot operations, and we'll go through that shortly in regards to how that works. But this is, in general, the syntax of some different expressions that you might calculate. Okay, so MATLAB, again, we said is short for Matrix Laboratory. So what we have, there's scalars versus arrays. So what's the difference between the two? To summarize, a scalar is something like 5, 2. You know, it's a single variable. So like when I was typing before, x equals 5, that is a scalar value. However, there are also arrays, and arrays are, I'll show you here. So we have x equals 2, 3, 4, 5. This would be considered an array. It doesn't have to be just numbers. It can be expressions, it can be strings, it can be variables, but that's just to give you the general idea of what an array looks like. So MATLAB considers all variables as arrays of numbers. You're using the 5 arithmetic operators. Again, we just discussed what those are in the previous slide, kind of showing examples of these in use. But they must obey the rules of linear algebra. So when the variables are scalar quantities, meaning that they just have one row and one column, you know, again, something like x equals 5. 5 is one row, one column in MATLAB. The usual rules of algebra apply, so there's no limitations there. However, when we get into vectors and matrices, we have to use the dot operations so that we can obey the rules of linear algebra. So how do we do dot operations? This only applies to multiplication, division, and exponentiation. And this here is the syntax that you will use. So instead of just using the star or the slash or the caret, you now have to place a dot or a period in front of these symbols in order to execute these type of operators when you're using vectors and matrices, also known as arrays. So let's take an example here. And let's say we have A is 1, 2, 3, 4, and B is 5, 6, 7, 8, 9. And we're going to go ahead and first we have to define these in MATLAB. Okay, so see a couple of things here. One, I have suppressed the output, so that's why there was no system response for me. However, I can see up here in my workspace that A and B have been defined as I specified. So now let's say I want to do A times B. we receive an error. Inner matrix dimensions must agree. Error using the multiplication symbol. So the issue here is that we have not obeyed the rules of linear algebra in regards to the multiplication. So the way that we get around this is instead we do dot multiplication, and we now see that we have an answer. And what this does is it's element by element multiplication. So you can kind of see where that comes from. So we have this first element here in our array is 0 times 5 is 0. 1 times 6 is 6. 8 times 2, sorry, I lied. 7 times 2 is 14, 8 times 3, 24, 9 times 4, 36. So again, it's performing the multiplication on an element by element basis. The same applies if we were doing exponentiation or division. Okay, so there's also some other syntax that's helpful for you to know when you're creating different expressions in MATLAB. So for example, if you wanted to use the expression e to the x, you would do exp parentheses x. Note that it is not e caret x. So we'll go back here. This, okay, see, it doesn't know what e is. However, I can do this, and it's throwing x in there from before, but we can do this and it will work. It does allow us to do that. So again, there's just some syntax and notation that you have to become familiar with, and so that's why one of the reasons why it's really important that you go through and read chapter 1 in very close detail, because it outlines a lot of this information for you that you're going to be using regularly throughout this course. Here's some more syntax. So square root of x is another one you'll use. Log, absolute value, signum, logs, factorials, primes. You know, these are our things you're going to see and what you will need to use as we do applicational problems in this course. Okay, so also built into MATLAB are trigonometric and hyperbolic functions. And so you can see here, we have sine, cosine, tangent, secant, cosecant, cotangent, all the usuals. However, there are different conventions here. One is for radians, one is for degrees. When your input argument for x is in degrees, so 90 degrees, 30 degrees, you do need to make sure that you use sine d, d of course being for degrees. If your input is in radians, for example pi, then you would just use sine, cosine, tan, whatnot. MATLAB also allows us to do the inverse. We can also do the hyperbolic functions, so sine h, cos h, and we can do the inverse hyperbolic functions. Okay, so let's just go ahead and do an example. What we have here is we're going to define as x as equal to 0.1, a is equal to 0.5, and then y is our expression that is provided here. So this will just kind of give you some practice with inputting some arguments into MATLAB and displaying an output to the command window. So we'll go ahead and copy this and display this into MATLAB, and we can see here that this has displayed the correct output of y equals 1.0736. So what we did is we defined x, which we must do prior to executing this expression. I should have mentioned that earlier, but any variables that you have in an equation, you must define them prior to executing that expression. So for example, if we did clear all CLC, let's say that we did this here. See how it says undefined function or variable x? What it's doing is it's going through this code and then it's stopping when it gets to x and it says, I don't know what x is. So again, you have to make sure that before you execute an expression that you define what that variable is. And there's a couple of ways to do that. One of those is just to say, you know, x is equal to, you know, 0.1 or 0.5. Or you can also use the symbolic toolbox, which we will go over what that is shortly. Another little helpful thing when you're using the command window is if you hit your up arrow key, it will scroll through your command history, what you've entered into the prompts. So if I just hit this up arrow here, I can scroll through all the different commands that I've entered here so that you don't have to go back and enter this big long expression again into your command window. So again, now that I've defined x and a, now it's able to plug these variables into my expression and compute the answer for y. Okay, so here's just some more syntax for you. One thing that's nice about MATLAB is it doesn't make you type out the value for pi every time. You can literally just type the word pi, P-I, and it recognizes that that's the 3.14159. You can also use I or J to indicate a complex value. So, the square root of -1, I or J, that's a typical convention, typical notation. That does not mean that you can't use those for to represent a variable for something. However, a lot of times MATLAB will give you a warning and tell you that that's usually used for complex numbers. If you need to use infinity, then it's just INF, real max, real min. You can read through these and kind of play around and see what those do. Some more notation. In MATLAB, we're used to the convention that an equal sign is just an equal sign. However, in MATLAB, when you're doing equals, you have to use two equal signs. When it's not equal, you're going to use a tilde and then an equal sign. And then the rest of these are just standard notation that we're used to seeing. Couple more things. So let's say that you wanted to round the outputs to the command window. You can do decimal to integer conversions, and you can control the output of the rounding. So for example, if you use fix, then that's going to round towards 0. So you can see here, even though the value of x was 2.7, it rounds down towards 0. Or if you used round x, then that's going to round to the nearest integer. So 2.7 became 3. There's also ceil x. That rounds towards infinity, positive infinity. So that's going to round up to 3, round up to -1, and then floor rounds to minus infinity. So those are just kind of some more options that you have in terms of formatting outputs and doing decimal to integer conversion. Some more notation that you're probably going to use. MATLAB does have the ability to handle complex numbers, and it allows you to manipulate those. So for example, abs of z. So we have z is equal to this, and so it's going to compute that for you. This is what it does internally when you use this ABS function here. It can also do the complex conjugate for you. It can pull out the real part, it can pull out the imaginary part. You can also do phase angles. So this is something that's really handy, especially as you get into circuits. If you know how to do this in MATLAB, it's very, very helpful. This particularly is going to become useful when we do statistics. Which that is several chapters from now, but we're definitely going to be covering that in detail. So let's say that we want to find the maximum value in an array or the minimum value in an array. We can find the standard deviation, we can find the average. It provides us all these tools right in MATLAB to be able to do that. So let's say that I go back to the one of these vectors that I created here. So we'll just take the b vector. Let's say that I have b equals 5, 6, 7, 8, 9, and then I want to find what is the max value inside of vector b. So if I do max b, it automatically tells me that the highest value in vector b has a value of 9. You can also do min b. So you get answer equals 5. You can also do mean. So you see, it has all these built-in functions that do the computations for you. So again, like with the circuits course, this is going to be really useful if you know how to do this in your statistics class, if you can do this in MATLAB. So we've kind of seen these now. The period is used for decimal points. Comma is just used as a separator. It can be used as a separator between matrix elements, so for example, let's say, so I had B before, and this particular notation that I used, I did not include commas. However, I could if I so chose. So you see the output there, but if I did like I did before where I didn't have commas, the output is the same. It's kind of a preference, more so in regards to readability of your code. There's a lot of times where your vectors and your matrices may not necessarily be just numbers. It can include expressions and variables, and they can get rather lengthy. So there will be a lot of times where it's actually helpful to put commas in between each of these elements for readability. Okay, so now what we're going to go over is creating scripts in MATLAB. So what you've seen so far is we've just been using the command window, the command prompt to execute commands for us. This is good if you just needed to do a quick computation, what is the square root of a number or something like that. However, more often than not, and particularly in this course when you are doing your homework assignments and your quizzes and whatnot, you are going to need to create scripts. And the way that we do that is we click on this button up here. It says New Script. So we click on that, and you see it opened up this new window for us here. It will always be untitled when you first open it up, and that's because we need to save it. Before you run a script, you have to save a script. So I'm going to show you how to do that before we go ahead and enter in some code. So click on the Save button. If you click on the little arrow, it'll allow you Save As. And what we're going to do is we're just going to call this Example Script. Okay, and so we can see here that now this script is over here in my current folders directory. This is really convenient, create folders, keep your files organized over here, as a lot of times when you create these scripts, it's because you want to go back and reference them later. So, again, now we can see this here. Take a look at this here, though, this .m. This is how MATLAB saves files. They're called M files or .m files. MATLAB takes care of that for you when you save it. But just note that, especially when you go to upload your homework assignments, we will specify that, as well as quizzes, we will specify that we don't accept anything other than your .m files. There can be .asv, .doc. Unless specified, we always want you to submit .m files. So again, now we have this script here. And so now that we can save this, we can use it at any point in the future if we want to. So let's go back here. When you're using the editor, it's best to use it if there's more than a few lines of code. So if you're just, like I said, if you're just using it for a quick computation, it's fine. But if you're going to have multiple lines of code, you're going to want to use a script. It's also good for if you're going to use the program again. It's great for permanent records. If you have to do a lot of debugging, this is definitely the way to go. And if you want to transfer your code from one person to another, or from one organization to another, then you're going to want to have scripts available. So we showed you, click on this little button here. That will open a new script for you. There's the script window. So now we're going to kind of show you some syntax and some proper techniques for when you are using the script window. So first things first, you have the ability in MATLAB to create comments. Comment is just $, and then you can say, this is my code. Okay, see how it shows up in green? This is indicative that you have created a comment here. As opposed to x equals 5, this is actually what would be executed when you run your code. So let's say that we have a homework assignment, and there's 3 different problems on the homework assignment. What you're going to have to do for your assignments is you're going to create sections for your problems. The way that you create a section is to go %, %. So we're using 2% signs this time. And we're going to close that. So we're using 2% signs. And what we're going to do is we're just going to say problem 1. So this here, you see how this particular part where I have context written is highlighted in a yellow color. The rest of this is white. So now let's see what happens when I go down and I create problem 2, problem 3. Okay, so you'll notice here, now that I'm clicked in this problem 3 section, this part is highlighted. Now problem 2 is highlighted. There's also this thin gray line that goes between each of the sections. The reason why this is useful is because when you have multiple problems that you're addressing in your code, we have the ability to use this Run Section button up at the top. And what that does is it means that we will that instead of executing every single problem at one time that's in your code, we can instead just execute what's here. So let's say, for example, we have x equals 5. And actually, you see here, see how there's this little wavy line? What this does is it's telling you that there's some sort of warning. If it's orange, it's a warning. If it's red, it's an error, meaning your code is not going to run. A lot of times with warnings, your code will still be able to run, but particularly if it's red, you need to address whatever it's telling you. And you can do that by highlighting over it, and it's telling me that I should suppress my output within the script. So now you can see when I put the semicolon there, now it's gone. So now it's not angry with me anymore. So now we can go like x equals 5, y equals 4, suppress that, and then I can go z equals x plus y. So you see I've suppressed this, I've suppressed this. I do not, however, want to suppress my output here. And this is because this is the answer that I want to display to the command window. So when I do run section, it tells me z is equal to 9. This is something that's really big on your homework assignments. Make sure that you don't just suppress everything. When we go through and run your code, we want the output, the answer to the problem to be displayed, and that can be multiple answers, so keep that in mind. But again, then we can come down here and we can just do, t equals square root of 3 and x, and we'll do something different. Let's do s equals absolute value of -2. So you see how, again, I can run this one, run section, it displays the output. When I run this section, it will display the output. I do have the ability to run the entire code. So to do that, you click on this little green button and hit run. And now it has displayed all 3 outputs for me. See how there it tells me example script, and then it's given me each of the answers to each problem in my code. So again, when you're doing your homeworks and your quizzes, as long as there are not functions present, which we'll get into that in the future, then you're going to want to use this particular format for your, do problem 1, problem 2, problem 3, and you can identify it, as problem 5.31 or whatever to help you identify specifically, which problem you're addressing. Okay, so we went over that. The important thing when you're creating the sections is to make sure that you put the space between the 2% signs and your text. If you do not do so, it is just going to create a comment. It does not create the section. Again, make sure when you're creating sections, make sure that that section is highlighted and that you have the thin gray line between each section. Otherwise, you have not created a section. Okay, so one more thing in terms of just general formatting with your code. It's always good practice to begin your code with these 3 lines: clear all, CLC, and close all. This is not something that you have to do. However, it is good practice. For whatever reason, there will be times when you will be using MATLAB and you'll just get weird errors. You know, you won't be able to figure out what it is, and you'll spend a while on it. And if you just try hitting clear all, CLC, close all, sometimes that will actually solve the problem, because what happens is that once you have a ton of variables in the workspace, or maybe you've defined something as T, you know, in 2 sections and whatnot, sometimes it just doesn't work in terms of computation. So if you do this clear all, CLC before each problem, then that will help to eliminate some of those errors. Again, this is just good practice to do. If you come back here, you know, again, so we know that clear all, it clears all the variables in the workspace. CLC clears the command window, and then close all closes the graphic windows, which we'll get into in the future how to do that. So just a little bit of key terms or some vocabulary to help you understand what's going on in your script. So we have inputs. This includes the numerous checks to ensure that all input values have the qualities required for the script function to work properly. That kind of goes, what that's explaining is that you initialized your variables for an expression first. And so it goes through and it checks to make sure you did that. So when I showed you earlier, when I tried to execute that expression and it said undefined function or variable, that's what this is referring to. It's basically saying that I did not identify a particular variable before I used it in an expression. And so when you do this input, it checks that for you. Computation is just where the numerical evaluations are performed. So it goes through and for example, it will, you know, put the variables into your expression and do the computation or calculation for you. Output is what you see in the command window. It's your answer or your system response. Okay, so real quick, just to mention, when you are saving your .m files, there are conventions, just like there are for creating variables, there are conventions for .m files when you save them. And this is actually very important because MATLAB is very picky in terms of what is acceptable and what is not. So you are limited to 62 alphanumeric characters. And like with the variables, it must start with an uppercase or lowercase alpha character. After that first character can be any number, any letter, or the underscore symbol. Again, you cannot use periods, exclamation points, hyphens, particularly spaces. For whatever reason, that seems to kind of get students with the file names as they try to put spaces in there, and you cannot do that. Your code will not execute if you have a space in there. For that reason, we have a naming convention for our files when you submit your assignments. This must be followed when you submit your assignments. So we want first name, last name, and then, for example, homework 1, homework 2, whatnot. Same with your pre-quizzes and your post-quizzes. You know, label them according to whichever assignment you're on. But make sure that this is the exact format that you follow when you are saving your .m files. Okay, so sometimes you have to go through this. When you're saving your first .m file, you see that I particularly did not have to, but you can add folders, you can browse for new folders, you can also change your directory. Sometimes this little box will pop up here. You know, if you go to run a code or a function file or whatnot, sometimes you'll see this editor window pop up, and what you'll want to select is change directory, and that'll change the current path to the file being executed so that you can run your code. Okay, so we went over this, running scripts, executing them. You know, again, to run the entire script, you're going to hit this run button here. to run a particular section, for example, problem 1, which you can see is highlighted here, you'll hit run section. You also have this run and advance button. So what that does is it will run this section and then automatically advance to the next section for you. So let's just show that in use here. So run and advance. So it ran the first problem, advanced to the second one. You see it didn't output the value for t to the command window, so it doesn't actually execute this problem. It executes problem 1, but then advances to the next problem. Okay, so this is another really important tool to be familiar with. MATLAB has a couple of different options in terms of help features. This is absolutely critical that you learn to use this because you will use it a lot. Doesn't matter how advanced you are of a MATLAB user, this is extremely helpful. So first you can access the online help features, and the way that you do that is go back to your home tab, and then there's this little help icon right here, and so you can click on the button and it will open up a new window for you. And when you want to use this particular option is when you don't know what function or what how to execute something. You know, a lot of times, let's say that, for example, absolute value. Maybe I didn't know what the function absolute value was ABS. Then I could search for that. You can click on MATLAB or any of these toolboxes, really. This is all going to go into detail. Most of the time you're going to click on this MATLAB link here, or you can just click on the search box here, and then it tells me I have some options. So when I click on that, I can see, oh, well, there's the syntax to compute the absolute value of an input argument. So that's really helpful. You know, there's information for days. You can read tons and tons of context in regards to how to use certain functions, but it's a really great feature, and again, I would definitely recommend that you get used to using that. In addition to the online features, you can also access help directly within MATLAB. So you can go, for example, help absolute. Okay. So we can see that when I did that, it tells me here what this function does. It gives you other resources that you can read about. It's not as detailed as the online reference. It kind of depends on what you're searching for. But there are times where it will give you examples on how to use the code. So for example, you know, if we're dealing with eigenvalues or eigenvectors, you know, it goes into a rather detailed explanation of how to use this particular function. It gives you syntax, it explains the syntax, and then sometimes too it will even give examples, example code. So that's a really useful feature. I would definitely recommend getting familiar with that. You know, again, the difference between the two, if you don't know what you're searching for, if you don't know the syntax or the function, use the online help. If you know what the function is and you just aren't sure maybe what the input arguments are, or you're getting an error, or it's asking for a parameter and you don't know what the parameter is, use the internal MATLAB help. Okay, so that's just what we went over. You can see there that it gives you some syntax as well as explanation of the syntax. The way that you format is you just go help and then the name of the function. So help absolute value, help eig, you know, and it'll give you more detailed information. Okay, so another important feature of MATLAB is that it has something called the Symbolic Toolbox, and what this does is it provides you the ability to perform computations and manipulations of expressions using symbols so in other words, you don't have to have a numerical value specifically to put into an expression. You can use symbols or the Symbolic Toolbox, and it will evaluate the expression for you using that symbol. So what does that mean? So we're going to go through a couple of different examples here. We're going to go over the syntax, and then we're going to show you a few different examples of using the Symbolic Toolbox with the syntax. So Here is the general structure of the Symbolic Toolbox syntax. So you're going to have sims, and then it can be ABC or just A, B, whatnot. A, B, and C are symbolic variables. And what's important is that you must put a space between each of these variables here. That's very, very important. If you want to restrict the variables to only being real, then you can do so using A, B, C real or A real or whatnot. These symbols can be intermixed with non-symbol variable names, numbers, MATLAB functions, but the results will always be symbolic expressions. So let's take an example just using some precision arithmetic. Let's say that we have this expression or this equation here. So we have f equals 11.92 e blah, blah, blah. So assuming that d equals 4.2, the script to represent this expression symbolically is the following. So one thing to note here again, e in this particular case is not a variable letter e. This represents what we talked about earlier, the exp, and then you can use the x. In this case, our input argument, instead of e to the x, it's the negative a squared. So let's go ahead and type this into MATLAB. And in this case, I'm just going to put that in for section 3 here. Go back to the editor tab, run section. And it's going to compute the answer for me. So you see here, I didn't define what A or B was in this expression. I only defined what D was. However, MATLAB was still able to evaluate it, and it was able to do so because of this symbolic toolbox. Again, these are symbolic variables. It's now created a symbolic object to where I can substitute constants in for that or whatnot. And it can still calculate a symbolic answer for me. So you can see here, that's the same expression that we received. In addition to just regular arithmetic, we also have the ability to perform differentiation in MATLAB. This is extremely useful, especially as you get into your upper mathematics courses. So what we have here is f of x is just this f here is your symbolic expression. So, cos or whatever you're going to use. X is the variable in which you are differentiating. And n is the number of differentiations to be performed. So let's look at an example. Let's say, and all of these examples are in your text, by the way, as we go through these, and they provide a lot more context, so be sure that you go through and read these. In this particular example, we want to calculate the derivative, first with respect to t, and then with respect to b. So here is the syntax that we would use to do that. So this expression here is used to calculate the first derivative, which is what this number represents here, with respect to t. And then here's our function. And then this one here, also the first derivative, but this time with respect to b. And so when we execute this code, if I could highlight it. No. Sorry. I don't have enough room to scroll over here. Okay. So when we go to execute this, I'm just going to create problem 3 now. And you'll see we can just go through this. So you can see the output. You'll see exactly what you do in the presentation. But what we have here is it calculated the derivative with respect to t, and then it calculated our derivative with respect to b. Again, I did not put any input arguments in place here, or like numerical input arguments for it to calculate specifically what the cosine of a numerical value is. This is symbolic, so that I can derive the symbolic expression. So, let's say that we want to define sims a. We could do diff cos a a1, and it tells me that the answer is negative sine of a, which Makes sense, right? Perfect. Okay, so in addition to differentiation, we can also do integration. It works very similar. The only difference is that now we have to or can provide the lower and upper limits of integration. Just a little note here, when C and D, meaning the upper and lower limits, are omitted, the application of int results in the indefinite integral of f of x. So let's do an example here. Let's take the integral. Okay, so let's say again we have those same two expressions, but this time we want to derive the integral with respect to b and then with respect to t. Okay, so now we see this time we calculated the integral. We used the int notation, and then that gave us the integral in relation to t and the integral in relation to b. Okay, in addition to integration and differentiation, we can also do limits in MATLAB, which is really convenient. The general syntax for the limit is this here. And for those of you who don't know, at this point I'm assuming you've all had your calculus, but in case you don't know, a limit is just a value or function, a value that a function or sequence approaches as the input or index approaches some value. So we'll go through an example so you can kind of see what that means. But again, this is the general syntax, and so f is for our function, x is our symbolic variable, and z is the limiting value. So in our example here, let's say that we have this function, okay? So f of x equals x squared minus 1 over x minus 1. What we have is when we move arbitrarily closer to 1, then the function f of x approaches 2. And you can see that here. If you plugged in these values, you can see that they approach the value of 2. And so we can calculate that using MATLAB. And that would be done through the following. So what we have is, and we'll go over what this function linspace does here, but we have x equals linspace 0.9, 1.1, and 10. And these are just representative of these values here. So we're plugging those into our function. This here is our function. Again, notice that we had to use the dot operations, the dot division, because this here is creating an array. We have more than one value there. Okay, so then we have sims x, so that's creating our symbolic variable, our function, and then we can calculate our limit. So when we execute this code here, we can see that our answer is 2, which coincides with exactly what we would have computed by hand. So again, this is really nice that you can just do this directly in MATLAB with only really a few lines of code. Okay, so another limit example. This time we're going to have the limit as a approaches infinity. You know, we mentioned earlier in one of the tables that the notation INF is what you use for infinity. So this time we're going to do sims a and b because we have both of these variables in our equation. And when we do that, we see that the limit is 2/3. You know, if you were to do this by hand, again, it'd be a little more complex, but MATLAB has the ability to just do it for you, which is really convenient. Okay, another example of a limit, you know, this is kind of just getting you used to the notation here. This time we're going to use sims y and x because those are the two variables. Again, we have as x approaches infinity. And execute that in MATLAB. Oh, that didn't work. Let's try that again. Copied too much. Okay, let's try this again. Bye. Okay, Sorry, hold on. Sims yx. Okay, y. Sorry, hold on. Must not have copied. There we go. Okay, so now we can see again when we execute our script, it's done it symbolically, and this exp to the y represents our e to the y, okay? So again, this is just kind of getting you used to the different notation and syntax and whatnot. So, again, with the limit, we have our function, we have our variable here, and then to infinity. So that's where those variables are coming from. Okay, so we can also do Taylor series expansions, and basically all that is you're expanding a function f of x about a point, about a given point, a. So this is the expression that we use to do that. That involves a lot of hand computations when we're doing this, so it's really nice that we can do this in MATLAB. And so this is the general syntax. You can see a lot of these are very similar in their structure. So now let's look at an example. Let's say that we wanted to obtain a 4-term expansion of cos theta about theta naught. So theta naught is our point, cos is our function, and we're going to do a 4-term expansion. And let's go ahead and execute that in MATLAB. Okay, so we used sims of x and theta naught, okay? So we did Taylor cos of x, that's our function, okay? X is our variable, theta naught is our point. Order, this is what's referred to as a parameter, and if you use MATLAB's help Taylor option, it gives you more details what this does, but you're pretty much going to want to use order unless you're just finding the first term. If you're finding more than that, you're going to want to use this order here, and it does need to be in the single quotation marks, and you'll know that you've done it properly because the color will turn purple. And then we said we wanted to find a 4-term expansion, so that's what this number here represents. So then we can see when we executed it, this is our output. So we have 1-term, 2-term, 3-term, 4-term expansion. And it really, it took 2 lines of code. Okay? So another thing that might be helpful is to do substitution. So let's say that we wanted to substitute one variable for another. So we have subs FAB, okay? So you have your function, and then you have your variable that you're gonna substitute in for another. So for example, we have the syntax here. We have sims x and z. Again, we're using sims because we don't want to input any specific numerical value. We just wanted to evaluate it in relation to this particular variable. So we have our function, which is f, and you see how this time we defined f, and then we just plugged f in here. If you didn't want to do that, you could do sine x. However, to prevent yourself from having to type the same function over and over, it's good to define it first and then just use the variable. Okay, and so then you can see that we are going to substitute the letter z in wherever we have x. So when we execute this, we see that it went from sine of x to sine of z. Z was substituted in for x. Okay, so that pretty much summarizes the chapter. Again, you're definitely going to want to go through and read this chapter in detail. It's the backbone for being able to use MATLAB. It gives you a lot of syntax, a lot of examples. I definitely recommend that you go through these example problems on the next few slides. It's kind of hard when you're first learning MATLAB. You're just trying to figure out what's the correct way to type in an expression or whatnot. Or maybe what function to use. And so these give you some examples of how to do that. Here's some Sims examples. You'll have the use of factorial. you know, using your sines and cosines, your trigonometrics, square roots. So definitely be sure that you go through and attempt these problems so that you can gain a really good understanding of just how to use MATLAB in general. If you have any questions, please email me and let me know. Otherwise, good luck, and we'll see you all later this week. Thanks. Bye.